All right, I think we're going to get ready to start this session. I'm still fighting with my voice. It is much better than it was on Monday. It gives me great hope that someday I'll actually be able to speak normally again. And that's opposed to coming back from Tech Ed Australia on Sunday night, in which I had absolutely no voice whatsoever. Panicked that I wouldn't be able to talk at all. So let me get a little bit of a census here. How many folks heard the other session that I gave, which was spatially enabling the database the other day? Okay, so I've got a bunch of repeats. This is good. This is kind of a follow-on to the other session. If I lose anybody, the folks that didn't hear the other session, I'm making a few assumptions that we did see that other session. But in general, this is still relatively entry-level. But today we're going to explore the cloud, and the good news is that the cloud is working from my computer. Often in the United States, I've actually had to resort back to a tethered wireless unit in order to do it. Oftentimes, for some reason, they like to block Microsoft's cloud from the hotels, and I can't explain why. I've got to figure that out. So, I'm Ed Katamov. I am the for SQL Server 2008 Katmai, I was the SQL Server Spatial Scenario owner. So I actually owned the implementation of that product. And now for the upcoming SQL Server 11, I am a member of the customer advisory team, continuing to help set specifications and to architect the next generation version. And I welcome all of you to please make contact with me if you have any additional questions, suggestions, hints on how we can do things better, etc. Okay, so I'm just going to reiterate this. You guys saw this the other day. This again is our design philosophy. The bottom line is this: we are attempting to make Spatial a first-class citizen. Hence the last line. Spatial is not special. It is simply another data type. Now, that is by and large true. However, some of you old hands in here will realize there is still some spatial speak that goes on, that you need to know the secret handshakes in order to be able to decode things like spatial reference IDs, and we talk about buffers, and sometimes people from other disciplines in IT think of buffers in a different way than we do. So there is still a special language, still some special handshakes, but we are striving to be able to make spatial not special in terms of what we develop from a core standpoint and from a breadth standpoint. This is my overview slide. Any of you not familiar with our approach and what we're doing, I advise you to take a look at this. The key takeaway here is two data types. One for flat earth, or anything that you can do in a planimetric fashion. For instance, the layout of a particular floor plan or show floor of the seats in this room. The other type is a true geotype. It is called geography, and it is intended to model the Earth as a single continuous unit sphere, no edges. So this is a very powerful type, and as I pointed out in my last session, if you don't know why you need to use the flat Earth type, then you should be using the round Earth type. So that's kind of the takeaway there. Okay, so let's talk a little bit about spatial in the cloud. First of all, before we get into it a little too much, I want to point out that SQL Server Spatial in Katmai, SQL Server 2008, we were the last major relational database to have these capabilities. Informix, whom I've worked for and done the same thing, IBM, Oracle, Postgres, MySQL, all had spatial type support. Why did Microsoft finally decide to do this? Because it looked interesting. So I was recruited to come in and help satisfy this need, and we've done a pretty good job, if I may say so myself. Done it a little bit differently than others, done it a little bit differently than I've done it in the past. Now the good news is, when it came time to do SQL Azure, it was as simple as turning on the spatial bits in Azure, because SQL Server Spatial in Azure is SQL Server Spatial in SQL Server 2008 with a few restrictions. and we'll go into those in a second. But let's talk a little bit about what a cloud database is. Some of my friends who remain back at IBM have argued that DB2 with a spatial extender or the geodetic extender sitting in AWS, Amazon Web Services, is indeed a cloud database. Well, I would argue that that is a database in the cloud. A cloud database, we have some attributes here, scalability, automated service management, and so on, which are sort of the tests that Microsoft likes to apply. And using this premise, SQL Server Spatial is the first spatial implementation in a cloud database. So we've gone from last in relational to first in the cloud, which is actually quite gratifying, and it works beautifully, as we will see in a few minutes. So again, what is SQL Azure? SQL Azure is nothing more than SQL Server in the cloud with some of the inherent advantages of being in the cloud. For instance, the fact that when we commit something in one data center, it is automatically backed up to another geo in another center, replicated. So some of these things are just automatic DBA style administrative features. And again, what is SQL Server Spatial? It is, from an application standpoint, with a few minor exceptions we're going to go into next, the same thing as SQL Server Spatial. So let's talk a little bit about best practices here. First of all, the web, and I want to emphasize this, is not your spatial development environment. It's remote, it's far away, it has a few limitations, and we'll see them here in a second. And so it is much better to do your development on a local copy. That's the way I do it all. That way you can guarantee you have scalability, and you will still find a few surprises sitting out there in the web because you don't get to control that piece of hardware. So let's take a look at another thing. Tables must have a clustered index in place. So if you attempt to commit a table from an existing SQL Server instance up to the cloud and it doesn't have a clustered index in place, it will fail to commit. So is this a big deal? The answer is no, especially for spatial. Spatial requires, if you want a spatial index, that you have a primary key on that table. A primary key by default has a clustered index. And so consequently, if you're going to run a spatial index in the cloud, which I would highly recommend that you do, you will typically have a primary key. You will typically have a clustered index, so no big deal. Now, a spatial reality check. You do not want to return large amounts of data. The SQL Server in the cloud, SQL Server in the data center, in a few milliseconds can return more information back than the best Ajax, FlashFlex, or Silverlight application can consume. You can overwhelm this. So you want to be judicious in terms of the number of and amount of vector data that you bring back, and you want to be judicious in the complexity of individual objects. We can store objects up to 2 gigabytes each. That's around 125 to 150 million vertices per object. That is way more than any web-based, vector-based application can consume. If you need to return objects back with that amount of complexity, you're going to want to rasterize them first. I'd recommend that you use a partner product. Eagle Technology here, you can wave your hand, has excellent products from, I have a hard time saying this word, Esri. I think of it as ESRI. I've been brought up that way for the last 25 years. So you want to use some specialty products that will actually make that job reasonable for you. Okay, spatial index should be created on unpopulated base tables. What does that mean? It means you're going to be loading into a live index. And why is that? Because 2 reasons. We don't support online spatial index builds. And it would be very nice if we did. Needless to say, you can imagine, I could easily imagine myself losing my voice and talking to my colleagues about why we should have this. But suffice it to say, there are no plans at the moment to do online spatial index builds. What does that mean? That means that we run the risk, if we create an index, of timing out. And on the web, there are strong timeouts. This is to guarantee that in a multi-tenancy environment, any one tenant doesn't overstay their welcome, as we could say. So you could consume more resources trying to build a large index on a very complex data set than SQL Azure will allow you to do. So an online index rebuild, on the other hand, would allow you to interleave, and it would time out or actually kind of go senescent on long index builds. And this is how the B-tree, clustered indexes, and other builds work. So in the meantime, before we can do that, and it will not be out in SQL 11, the next generation, so we can hope for SQL 12, can't even tell you when that's going to be, you must load into a live index. And we're actually going to demonstrate that here in a few minutes. Okay, lastly, SQLCLR.net is not supported from your standpoint in SQL Azure. That means our CodePlex site, now I'll take a quick census here. How many people are familiar with the SQL Server Spatial Tools CodePlex site? Okay, not too many. So our development team has a CodePlex site in which we have extended SQL Server Spatial in a bunch of interesting ways, put the source code out there, used the library that we run against, and that library, again, is freely available, no charge, available in SQL Server feature packs. You can extend SQL Server very nicely. Now, you ask, well, hold it, what about SQL Server itself? Isn't SQL Server itself a CLR UDT, user-defined type? And the answer is yes. But being on the inside, we have special privileges. And so we extend those special privileges only to ourselves. In general, you may not go through and register a new assembly with new functions, new types, new aggregates into SQL Server Azure. And we are looking to expand that, but as you can imagine, there are large security implications. So consequently, from at least this initial outing, you will not be able to run any of the functions that we surface, nor will you be able to add your own through the CLR. So with that out of the way, let's take a look at some interesting things here. So first thing I'm going to do is I'm going to bring up my Management Studio instance here. And you will notice over here that I've got a funny named SQL Server instance up here. I'm not even going to attempt to give you the first part of that because it's a machine-generated name, but it is always followed by database.windows.net. And in this, I've got several databases configured, including one here called Kern County 4326. Now, any of you who were in my previous session, you will recognize that this is indeed the same database that we were using. Now, what I'm going to do is I'm going to delete that database out of SQL Azure just so I have nothing hidden. This is the reason I have my sleeves rolled up, right? There's nothing hidden in my sleeves. And what I will do is I'm going to come over here and I'm going to make sure I drop the right database. It would be just like me to drop the database I'm going to be transferring from. So I'm connected, if you notice down at the bottom, I'm connected out here to SQL Azure. And I am now going to drop that database. If I come back over here, I hit F5 to refresh. I come back, and notice that database is gone. Nothing hidden up the sleeves, right? Okay, so now I'm going to come back, and I'm going to go into my SQL Server Release 2 2008 instance, and down here I've got this database, Kern County. And what I'm going to do now is I'm going to transfer the database from that instance, which is actually on my machine, up into the cloud. And I'm going to use a tool which was created and is available on CodePlex called the SQL Server, the SQL Azure Migration Assistant. There are other ways to do this, by the way. This is just one of the ways. So with that, I am going to go to my SQL Azure Migration Wizard, fire it up, and now what I'm going to do is I am going to migrate and analyze and migrate this database and generate a script. And let me see if I can't, I had this happen before where I can't actually see what I'm doing because of the resolution. Is there any ability to change the resolution on this at all? No. So I'm going to guess. And I've guessed correctly, at least initially. So now I'm connecting to my local instance. On my local instance, I see a series of databases. I'm going to choose Kern County 4326. I'm going to connect to the server. I already connected to the server, pardon me. I am now going to say, yes, this is what I want. I'm going to script all my databases, generate my script, and off it goes. So now I've generated basically a bulk copy script via this wizard. And now, I hope, okay, I'm going to connect now to SQL Azure. And in SQL Azure, I'm going to create a new database to receive this one. Okay, come on, I'm connecting actually to the SQL Azure data center, which is the Midwest data center for Microsoft, located in Chicago area in the US. I'm going to create a database. That database name I will call the same, Kern County 4326. And you notice here I have a selection of sizes here that I can create. You will be billed based upon which size you select. 50 gigabytes is our new limit as of June. Prior to that, it was 10 gigabytes. I've been told in confidence, and I'll share with you, that these amounts will go up, but they will go up slowly as we gain more experience what's it like to actually move and manipulate that much data. And bear in mind, there are guarantees in terms of high availability, so the more data that you have out there, the more difficult it is for us to make those guarantees. So we're entering into this somewhat cautiously. I'm going to create the database. That's good. I'm going to hope that this is the right button to press for next. Yes. And off it goes. So at this point, I am pushing up that database, fully scripted in BCP, to the database server, including the indexes. So when it built the tables, it built those tables with a spatial index already in place. And in a few seconds, fortunately the progress bar isn't very accurate in this particular application and will be done much sooner than is indicated by the timer there. Come on, Chicago. Here goes watercourses. And I think watercourses are the last one.
So just a quick question, if you want to do this, if you want to create an index, you would do it.
If you wanted to create a new index, right, what you would typically have to do is you could give it a try in the cloud, but if you timed out, then you actually wanted to test that index locally on a SQL Server instance, and then create that and push the data up into that live index. And remember, SQL Server can have up to 249 spatial indexes per spatial column. So, if you have any doubts about what you want, you can actually give it a range. But typically, you want to flesh all of that out. Again, this is why the cloud is not your spatial development environment. You want to flesh all that out on a local version of SQL Server first. Okay, so it's done. We're going to exit this application. Now we're going to come back here and we're going to move over to, I'm going to give you a little bit more real estate so we can see here. But let's come back over here and go back up to our SQL Azure instance. I'm going to come over here, refresh this. I said refresh. Okay, let's see if that actually refreshed. And there we go. We've got Kern County 4326 up there. Now I'm going to do the same trick I did the other day in my demonstration, which is I'm going to attempt to visualize this in SQL Server Management Studio, but I already know I'm missing a table, so we're going to generate an error here. And there's our error. Unknown union. That's not the error I expected. So anyway, let's go ahead and we will notice here that when I expand the tables, I am missing, this is my goal, you can really tell I don't have things up my sleeve here, is I want to have some fire station point locations, and I'm missing that table. So what do I have to do here? Do I have to reload the entire database back up again? No, what I can do is pull up a tool, and these tools I'm showing off for the very first time to the public. They're in alpha right now. These are a series of tools which we call Spatial Essentials, and one of them is a shapefile loader. So again, how many people have heard of not heard of shapefiles? You've never heard of them. Okay, if you do anything with Spatial, you will hear of shapefiles. Shapefiles are an industry standard format. Azure put this particular structure for spatial data into the public domain many years ago. There is a single document that tells you how to do this. There are 15 versions of that out in the wild now. So just to give you an idea. But you will run across that extremely common spatial data format. It is not a single file, as the name implies, but it's actually a series of files which basically wrap up spatial data, attributes, projection information, and some additional file types which indicate local indexing and so on and so forth. But suffice it to say, if you're going to work with spatial data at all, you will run into these file types. So I'm going to actually do this from scratch today. I'm going to bring up the shapefile importer. Here it is. The first thing I'm going to do is I'm going to go select my missing shapefile, and here it is. Firestation.shape. Okay, I've located that. It told me that there are 69 records in there. It also, notice over here, says by looking at the .prj file, the projection file associated with the shape file, it has said, oh, we recognize which type this is, and it automatically is assigned an SRID of 4326. This is a part of the spatial still is a little special, a little secret handshake here. This is an EPSG number. EPSG is European Oil and Gas Petroleum Association, which has a series of numbers which relate to full definitions of projection types. What's a projection? A projection is when we go from latitude and longitude, which is unprojected data, to projected data like universal transverse Mercator. What's the name of our local transverse Mercator grid here? Just New Zealand transverse Mercator. What's the one for Australia? Oh, come on. Okay, but suffice it to say there are many in the United States. One that's very popular are the the state plane zone coordinates in California. There are 6 of these zones. They're all built upon Lambert conformal conic projections, each with special projection parameters. And we get into a whole bunch of voodoo, but basically it is the ability to take a round Earth, a portion of it, and flatten it with minimal distortion, but we will always have distortion. Now, in this particular case, this is unprojected data, and it is recognized as such. 4326 is spatial talk for the WGS84 ellipsoid, which for all of you know, even if you don't think you know it, those are GPS coordinates. That's what GPS units natively produce. So this tool attempts to reconcile that, because what SQL Server needs is not that well-known text string down there which describes it in industry standard terms, but it actually needs that SRID, because every single spatial object has an SRID associated with it in our object model. And our object model, by the way, just to reemphasize for those who already know and for those who don't, stores X and Y, or latitude and longitude, Z, M for measure, but it actually can be any floating point value, and the SRID for every single object. Now, what does that buy us? It buys us some confusion because we can, in a single column of Spatial, have intermixed objects with different SRIDs. So those of you who attended my other session, don't answer this. For those of you who weren't there before, if you wanted to guarantee that a column of Spatial only held one kind of SRID value, let's say 4326, what standard relational way would you do that? Very easy. We don't actually support that as part of the unique index, but you're getting close. A constraint. We would simply set a constraint. And we have a method called STSRID. And with that method, we can inquire as to what the SRID is of a particular object, or we can set the SRID. And you can use that in a constraint to guarantee that you only have one SRID value. Okay? So we're relying on standard relational tooling rather than other metadata tables, which is the way that Oracle Spatial does it, DB2 does it. In fact, everybody else does it the other way. Postgres, on the other hand, with PostGIS, does the same model that we do. They actually store the SRIDs as part of the object model. Okay, with that little diatribe out of the way, we will now move over here to our data columns. Now, in a shape file, there is a .dbf file, DBase file. And in that DBase file is a full description of what we call in the business attributes. And all of these attributes now here are shown. This particular tool gives you the ability to select which ones you want. But importantly, we need a primary key. So we're going to use a primary key based upon an identity type, which does not occur in the DBF. And often you will find shape files do not have a suitable column for a primary key. So this particular tool will make sure that you can do it. I'm going to get rid of the row GUID down here, which we don't need. And I'm now going to go to our target database. Now, in this particular case, our target database is going to be SQL Azure. So what I'm going to do is I'm going to pull up my cheat sheet, because my cheat sheet has on it, you even saw my password there. Boy, I'm in big trouble now, huh? Okay, so choosing that, I'm going to copy in that wonderful name. I'm going to pick up my database name, Kern County 4326. Schema is DBO. My table name is going to be Fire Stations. Okay, and I'm going to use, you have to use, Windows authentication is not supported in SQL Azure, so I'm now using SQL Server authentication. There's my user, and there's my password. I'm going to execute to target. I'm not going to do anything special here. In terms, I'm going to create the table. I would drop an existing table. I'm going to insert all rows. And with a little bit of luck, we're actually going to push data directly from a file on this machine into SQL Azure. In a few ticks, it will be done. If this were done locally, it would have been done in milliseconds. It takes a little while to push up. And remember, we're also pushing up chunks here, right? And why are we pushing up chunks? We don't want to do one long transaction. We want to do many transactions. And I believe we probably buffer, every 100 transactions. In this case, it was all one. Okay, no errors. That looks good. We'll get rid of that. And now we'll attempt to refresh this again. That went awfully fast. Let's see if it actually did anything. And there's Fire Stations now up in SQL Azure. So again, nice straightforward tooling. This is exactly how you would push data up into SQL Server. So there we just chose a SQL Azure instance as opposed to a local SQL Server instance. From the end user standpoint, no change in behavior or functionality. And now let's see if we can go figure out, oh, I see what happened. I did something bad here. Okay. Okay, that looks a little bit better. Now, what am I doing here? I am going through and doing selects. And I've got this thing completely messed up, so it'll be a miracle if it works. I'm going through and doing a bunch of selects, and I'm currently connected to SQL Azure. And by doing union alls, in our visualization tool, I can basically stack a whole pile of individual queries together. Union all, great little tool. However, it has a limitation is that you must return the same number of columns in every query. So in this particular case, I'm just going through and returning back the geography column, which I've named geog. So let's do that. And I'll execute that. And notice what we're returning back here. We're returning back hex. And this is pretty unuseful stuff. Now, if I wanted to be a little trickier, I could use something such as a method ST, spatial temporo, that tells us that this is an industry standard method as defined by the Open Geospatial Consortium, simple features for SQL version 1.1, also defined in SQL MM Part 3, also defined as ISO 19125. All of these are harmonized standards. So ST as text. Can anybody tell me why the capitalization is important in our implementation? Have to have the capitalization that way. Why? Meti. Why is it case sensitive? Remember, common language runtime. What's common language runtime? .NET. .NET is case sensitive. If I were to take this and put it in lowercase s here, and this has nothing to do with SQL Azure, has everything to do with SQL Server Spatial. I'll execute that. Can't find the method. I changed this to a capital S. And not only does it find the method, it works. And notice now we actually have a textual representation of that spatial object. This textual representation is known as WKT, well-known text. We also have something known as well-known binary and GML, geographic markup language. But this is the other way of taking a look at it. But nevertheless, a database administrator or an end user looking at this really can't make hide nor hair of this thing. However, if we get rid of this and return the objects back as their native binary types, which is what we just did, Management Studio can interpret that and actually draw a map from that, which will give us a fighting chance of understanding what our query is actually attempting to do. And there we go. And it looks like my zoom controls are just outside of my active window, so I can't, yep, there they are, get to them. And so notice down here that when we do point renditions, it doesn't matter whether we're SQL Azure or SQL Server Spatial, we did something real smart, right? We basically turn a pixel on or off. It makes them very difficult to see. A tricky way to get around this, and I'll show you some other ways in a minute, is, let's go back to Fire Stations, is to buffer this. So now I'm using an industry standard term, method, spatial temporal buffer, and I'm going to give it a radius of 1,000. When you're working in the geography type, the vast majority of time, but it's all defined by the underlying coordinate system, in this case WGS84 is going to give you units, linear units in meters. So that's 1,000 meters, that's 1 kilometer. So now when I do this same query, little bit too exuberant there. And that's exactly what happened to me before, apparently. This is what happens when you get really fast machines. Okay, so now this will finish executing in a second, and those points will all be enlarged, buffered, by 1 kilometer, and now we'll actually be able to see them. Not an ideal way of doing things, but sufficient. Again, we don't want this tool in the particular instance inside of Management Studio. We're not trying to build a GIS, and that's something, again, I want to emphasize. SQL Server is not a GIS. You want a GIS? Go to the big boys, the Esris, the Intergraphs, the Map Infos of the world. There's where GIS is offered. Okay, so now we'll zoom in a bit. And you can see those fire stations now are represented as individual polygons or round objects. People who know the answer don't answer this. People who think they might know the answer but don't for sure, tell me, why are those circles not circles? They're actually ellipses. Why are they ellipses? That's correct, because this particular projection is really a non-projection. We're treating latitude and longitude as rectilinear, which is an incorrect way to do things. So what would we see here if we took it from equirectangular and turned it into the Bond projection? Well, we would see a tremendous change in how the objects look, but we'd also see them represented as perfect circles, or close to perfect circles the way we expect. Okay, just wanted to throw that one out there. Now, let's go down here and let's do another query. And these are the same queries that I did the other day in the database. So all of you who've seen that once before will see it again, but I'm going to show you some more interesting stuff here in just a few minutes. But here we have all of the objects from the city limits and those fire stations. So what we're going to do next is we're going to do an intersection, a spatial operation, in which we just show those point locations which are inside the set of city polygons which are distributed, as you can see here, throughout the county. Okay? So you can see some points in, some points out. What kind of operation would we do in relational terms in order to do this? We do a join. So we're going to do a join, and that join is going to use ST intersects as the core join method. So over here, if we look at this, what we're going to take is we're going to, is this my join? No, this isn't my join. This is my join right here. So basically, I'm going to join the, here's my from statement. Let me go move that down here for ease of viewing. We're going to join fire stations on city limits where city limits intersect. Now this is important here. We're intersecting using the ST intersects, and notice equal 1. This is a Boolean. SQL Server equals 1 says true, equals 0 is false. You could also rewrite this the other way and say 1 equals. Anybody know what happens if we do that? Something very special in both SQL Azure and SQL Spatial. The index doesn't get used. So this is important to recognize. You want to write your Boolean operations this direction, otherwise spatial index will not be used. You'll then go and take a look at the plan, and you will say index isn't being used. You then send me email, and then I just cut and paste from previous emails and tell you why. Okay, so let's actually go ahead and do that join. Okay. And in a second, we'll get it back. We can actually then zoom in. And now you notice we just have those point locations which fall inside those particular polygons. So what's the takeaway here? This is standard SQL. This is helping push the notion that spatial isn't special. We're just using standard joins here on data using these new spatial methods in order to do our correct vision or workflow or however we've set it up that we want to process our information. Okay, so that's pretty good. So we're not going to beat a dead horse on that anymore. So let's go take a look at some other ways to visualize this. Well, before we do that, I do want to do this. I'm going to go run you through a few sample implementations. These are things that partners have done out there on the web in SQL Azure, and in fact, in Azure itself. So you have a fully contained application environment out there, which is really the promise of SQL Azure. It's not dealing directly with it, it's dealing through Azure and actually creating well-formed final end user implementations. Now, this is just an example. This comes from map.net, but it gives you an indication of the kinds of architecture. Over here we see SQL Azure on the left side. There's Azure Storage on right below it. And down over here is the Windows Azure web role in which map.net, and it doesn't matter whether you're Esri, map.net, Intergraph, they would all attack the problem the same way. This is a classic diagram of how to deploy in the Azure environment. And we'll see that here in a second. So with that, let's go to where am I going to? I don't want that one. Well, actually what I'll do is I'll escape out down here, and here we go. So this is ESRI's Map-It. How many people have heard of Map-It? Okay. How many people heard of Map-It because of my previous session? Map-It isn't going to exist as such much longer. Esri is rolling it into their ArcGIS suite. So this is a Silverlight-enabled IIS environment. Typically uses SQL Server Spatial. It is fully .NET, which is a change for ESRI. Typically they're Microsoft COM based, and they've done a wonderful job here of writing an SDK. This is not a program. It is an SDK in which you can do your development, but it is extremely powerful, and it will be offered through ArcGIS, typically as part of the Microsoft Development Environment Suite. I'm going to take another throat lozenge so I don't lose my voice here. And what we see here is a backdrop of Bing Maps in which we have vectors selected from the United States Census block groups. There are 211,000 of these polygons. We've selected just a small portion using a Silverlight tool, and as we fly over, we can actually see things like the age distributions. ESRI is making use of Silverlight here in a completely Azure-hosted environment with SQL Azure holding all those vectors and supporting spatial operations and inquiries on them. So this is technology that's ready to go today. And one thing I will point out over here, additionally, is we can call other web services from this. And here's an example of drive time polygons. So I'm going to click drive time. I'm going to push this right over here on my building in Redmond, building 35, and it's going to go out there to another web service instance, maybe not even hosted on a Microsoft environment, and it's actually bringing back drive time polygons. I'll go to a new area over here so we can see it a little bit more clearly, drive time, and I'll select if I can do that correctly. And there are 1-minute drive time polygons being brought back. So this indicates that this is a beautiful environment for not only generating your own application, but calling in web services from other applications and building up an extremely rich environment. Okay, so let's go from there to a map.net application. Map.net, small company, ISC Consulting. They also do work completely in the Azure environment, or you can host their machinery on your local machine. This case, this is a 311 application. Anybody familiar with 311 applications? They're basically government. It's not a formal thing. It's kind of an informal. 911 is the emergency number in America. So if you have a a problem, you pick up your cell phone, dial 911. In fact, all cell phones, even when they're locked, have to support 911. But in America, it doesn't necessarily mean that the people you talk to know where you are. Brilliant advance there, eh? But this 311 is public information feedback to government. So in this case, these are where abandoned cars are, tree limbs are down, trash cans are tipped over, dead cats are left in the road. It looks like San Francisco is completely deteriorating here, doesn't it? So we can do things like click on that particular value, does a request out to SQL Azure, and it returns back. And over here we have a sidewalk cleaning, description, overgrown tree. Let's see what happens here in Golden Gate Park. Here we have another overgrown tree, request into the Bureau of Urban Forestry. Here we have another one, sidewalk, a lot of sidewalk cleaning. Sounds like we have dirty sidewalks there, eh? Damaged tree. Lifted sidewalk, okay, case where tree roots have lifted the sidewalk. So this is designed to be a public input tool. Folks would go to this site, locate themselves either by address or direct browsing, and then they could actually enter information, goes up into SQL, or up into Azure, and is persisted in SQL Azure. You can also do neat things like do hotspots. This is turning the basic request set into where are the highest number of these incidents. Can't query this. This is raster data, but gives somebody overviewing this the ability to make some informed decisions. That was point data. Here's another example in Miami, Florida, of polygon data being draped across a fabric, again over Bing. And then lastly, what I will do is I will show you an example of some a new application which has actually been put out on CodePlex as open source. So any of you, really dying to get your hands on this, you can do this either on your own servers or you can do this in the Azure servers. This particular application, which is called the Data Connector, and what I'm going to do here is I'm going to select buffer. And I'm going against U.S. counties, and I'm going to go through and just select those U.S. counties which fall along this linear buffer that I'm creating. So I'm going to go draw a line, it buffers it, draw another line, buffers it, and now it's going to do an intersection against that, and it's going to intersect that against U.S. counties, and it's going to return a result from Chicago right now. So there you go. So all of that is using SQL Server functionality, in this case SQL Azure, spatial functionality out in the cloud. If you're interested in this and want to play around with it, you can go to the Data Connector in CodePlex. How many people don't know what CodePlex is? So CodePlex, again, is our open source repository. And I've given at the very end of this presentation on the slide set a complete set of resources. One of the resources is this particular application. So all the source code is there. You're welcome to go have a go at it. Take it, download it, make it your own, and have fun with it. Okay, so let's go back to the presentation and just see if I have anything more significant to say. Let's see here. And I think the last thing really significant that I have to say is this resources slide. And there it is. A couple of things. Anybody who's interested in our object model and actually how we have implemented SQL Server Spatial, they can actually go to our specifications down over here, and we have a full publication of our on-disk binary format. Again, nothing up the sleeves. You can see exactly how we've created the object model, what we store on disk. Additionally, our library is fully specified in the SQL Server types namespace document also down here. There are a couple of books out here if you want to get your your hands dirty. There's an excellent one which is Beginning Spatial with SQL Server on A-Press. I've written a chapter along with one of my colleagues, Isaac Koonin, Inside SQL Server 2008 T-SQL Programming. Chapter 14 gives another kind of take and view, and I work on workflows typically in there, as opposed to an encyclopedic dissertation. That's what the first book from APRES does. That covers every single method. That talks about the data types in detail. I talk more about workflows, things like joins and other things that will be of interest. So what I'm saying is they form a nice complementary pair. So anyway, I would encourage you to take a look at the spatial resources slide. And with that, I think we've got about 10 minutes left. We'll open the floor to questions if anybody has any. Yes, sir.
When is the shape loader being released?
So this shape loader as part of the Spatial Essentials suite is currently in alpha testing at this moment. If you think that you could contribute to the alpha testing of this, I'd be happy to take your name and let you have a go at it. But my guess is we'll probably release this suite of things sometime, let's say in probably 6 months to a year. Next question. Don't be bashful. I don't bite. No more questions on SQL Azure? It's pretty easy. Okay, with that, thank you very much.